Assalamualaikum and hello. We are Group 3, Pest Detective. So, for this presentation, we will explore the invasion of the lionfish, Pterois volitans, an invasive predator disrupting our reef. So, this is our group members.
Indo-Pacific lionfishes, Pterois volitans, have bright stripes, long pectoral fins, and venomous spines. They look beautiful but are very damaging marine predators. These fish are originally from the Indo-Pacific region. Now they are a major invasive species in the Atlantic Ocean, the Gulf of Mexico, and the Caribbean Sea. This happened because of environmental changes and human activities.
Now I'm going to present why lionfish become the invasive species. This is because it can adapt to the different environments so that can grow rapidly. It also carry a venomous spines which will release the toxin and will harm to the marine organism and contributes to the population of native species decline. Lionfish is also a skilled hunter that consumes many native fish, and this will cause a sharp decline in the native population and reducing the overall biodiversity. When and how they arrived to Florida. First found outside their native range in the late of 1980, and genetic studies show that the inversions began from a single release in Florida, likely released from the aquarium crate. Due to their bright color and strong body, lionfish become a popular ornamental fish, and the irresponsible owner released the lionfish to the ocean. This slide is showing the global distribution of lionfish. The green area is native range of lionfish, which include the Indo-Pacific region, and the red area is the invaded range where lionfish has been introduced and become the invasive. The blue area is a potential spread and suitable habitat zones predict based on their environmental condition.
Now I will talk about the main problem caused by the invasive lionfish. This fish is well known for its beautiful stripes and long fins. But behind its beauty, it causes serious harm to our ocean, especially in reef areas. The first major problem is that the lionfish destroy the natural balance of the reef ecosystem. They are very active hunters and they eat many small native fish. These small fish play an important role in keeping the reef clean and healthy. When the lionfish remove too many of them, the reef become weak and loses the balance it needs to survive. The second problem is the lionfish reduce the population of important small fish. These small fish help control algae and support coral growth. Without them, algae can grow too fast and cover the coral. This makes the reef less colorful, less healthy, and less able to support the other marine life. Over the time, the whole reef begins to suffer. Another important issue is the effects on fishermen. When lionfish eat too many young fish, fewer fish grow into adults. This means fishermen have fewer fish to catch. Fishing trips become longer, catches become smaller, and income can go down. This shows that the lionfish invasion does not only harm the ocean, but also affect people who depend on it for their livelihood. The next problem is the lionfish overpopulation harm the entire food chain. When small fish disappear, larger fish lose their food source. This creates a chain reaction that affects many levels of the ecosystem. The reef becomes quieter, less active, and less able to recover from stress like storms or rising temperatures. So, this problem shows that the lionfish are the real threat to the reef ecosystem and to the people who depend on healthy ocean.
Now I'm going to present what is the possible approach. The first one is natural control. Areas with more native predator and competitor have fewer lionfish. The predator naturally reduce the lionfish number through hunting. Competition for food and habitat limiting the lionfish growth. It can promote native species, help naturally control the lionfish population. The second one is directed fishing and removal effort. The density of lionfish will be affected by the higher fishing pressure, including the commercial harvest and also landing. This fishing pressure contributes to control the population of lionfish and help to prevent the future increase. The following approach is community program, which is organized the removal program to encourage the community participation in lionfish removal. For example, Florida Lionfish Festival organized since 2019. And this example Florida Lionfish Festival since 2019. It includes two-day hunting competition, restaurant week, and community festival. 104,947 lionfish removed by November 2025, with the highest record in 2023, which is 24,699 lionfish has been removed.
Lionfish are an invasive species that have a potential negative impact on our native wildlife and habitat. Lionfish Removal and Awareness Day was created by the FWC in early 2015 to encourage removal of and to raise awareness about lionfish. This day falls on the first Saturday after Mother's Day each year. More than 2,000 lionfish were removed from Florida waters by those participating in Lionfish Removal and Awareness Day.
The following approach is trap. Trap is placed in the deep water to catch a lionfish. It is designed specifically to attract and capture the lionfish using the visual and bait cues based on their behavior and only allow the lionfish to enter and capture. Robot is also added as the possible approach, which is underwater robot are used as the mechanism removal device. It can capture the lionfish in deep reef beyond 13 meters, which is unreachable by diver. It also improves the efficiency and safety in biocontrol effort.
However, each control method has its limitations or side effects, which is a factor that cannot be ignored in environmental governance. Natural biological control is undoubtedly the least impactful and most effective method in most cases. For example, data shows that lionfish density is lowest on Dry Tortoise Island because there are more lionfish predators and competitors for the same species. While natural laws are certainly one of the best solutions to invasive species, their effectiveness can sometimes be less than ideal in different regions and under different conditions. For instance, in the Florida Keys and southeastern Florida, the population density of many lionfish predators has been significantly reduced due to overfishing, greatly diminishing the natural biological control over lionfish. As a form of human intervention, targeted harvesting and removal of lionfish has the least impact on other organisms. However, the drawbacks of this method are also obvious. The required manpower, financial costs, and the time cost of continuous monitoring of population dynamics are all very high. While fishing and diver removal operations are primarily limited to shallow waters, resulting in seemingly successful catches in these areas, lionfish populations may persist or rebound from deeper, uncontrolled habitats, continuously replenishing the shallow waters, a situation that is merely treating the symptoms, not the root cause. The potential dangers faced by divers during this process must also be taken into account. Community engagement is another way people offer help, but it also suffers from the problems we mentioned earlier. It doesn't address the root causes. Furthermore, public enthusiasm can change over time, affecting the effectiveness of this approach. Therefore, it's more of an educational method than a long-term plan. Selective traps have similar troubles, unable to solve the fundamental problem, and they need people to watch them and collect the catch all the time. This is because if a trap is forgotten, the lionfish inside can rot and hurt the ocean environment. Also, even if these traps are good at selecting lionfish, they can still catch other animals by mistake. This can harm other marine life. Currently, robotic fishing technology shows great promise. However, additional financing and testing are needed for wider adoption to guarantee its efficacy. Furthermore, many undeveloped communities cannot afford these robots due to their exorbitant purchase and maintenance expenses. For example, the Guardian LF1 robot mentioned above costs over $1,000 per unit, and subsequent maintenance costs are predictably high. Operator training is also a time-consuming factor. Therefore, it is foreseeable that the robots will still require time to be deployed.